Cool. So, how many people know about? I know you have already read. So, how many people know about the recursion, like what exactly recursion is and how it works? Cool. Um, First of all, let me address Ria's question. Yeah, what Riaz, can you ask your like doubt? What doubt you have? I'm just waiting for read line is whenever we are reading input from the terminal. That is called read line. Whenever we are reading the input from the terminal. Okay, that is called read line. Cool. So let's get started with the recursion today. So a recursion is something in which we'll be calling function itself inside the particular function that is called recursion. So let me add one page first. One second. Cool. So my voice is clear, right, everyone? I'm audible loud and clear. Cool. Cool. So first we will be covering, I will be just explaining you about the recursion. Let's first read the definition which is given in the slide and then we'll be going ahead. So recursion is something whenever we are calling a function inside the same function, that is only the recursion, right? So like why we use recursion, what is the use of recursion? We'll be going to that particular thing. Okay. So one second, yeah. So recursion is something whenever we have a big problem, whenever we have a big problem, we will break down that problem into the smaller problems, and like this, and we will be getting our result by solving our smaller problem. We'll be getting the result. So this is the exact uh, uh, thing why we use recursion. So for example, if we wanted to calculate n factorial, okay, so that is our big problem, right? That is our big problem. Like we wanted to calculate n factorial. So what we will do, instead of yeah. So n factorial is a bigger problem, right? And once we will break this problem into a smaller problem, how we'll break this into the smaller problem? N minus 1 into n, right? This is the smaller problem and this is the bigger problem, right? And as we will go down, we'll be breaking it into the more smaller things. So for example, n minus 3, n minus 2, right? So here what we are seeing, we are breaking our bigger problem into the smaller problem, and we are trying to do same thing. What do you mean by same thing? Here, if you will notice, we are only performing multiplication on each level, right? On step one, we are performing multiplication. On step two, we are performing multiplication, and on step three, we are performing multiplication. So, recursion is something in which we will break our big problem into the smaller chunks, and we'll reach towards our result. That is the meaning of recursion. Any doubt till this point to anyone? Any doubt to anyone till this particular problem? Cool. So there are couple, like how you will figure out where you need to implement recursion. That is the second question. Okay. So I will write it here. Mhm. So problems related to recursion. Okay. So we can wherever we are using for loop and while loop, that is nothing. That is just a recursion, right? We are calling a set of set of set of lines or set of code or set of logic multiple times, that is only called recursion, right? So problem, like for example, if we wanted to get the result of n factorial, if we wanted to get the sum of n numbers, if we wanted to check whether our array is sorted or not, right? If we wanted to check whether the given series is Fibonacci series or not. So these are the, and this list is very long. So as we will go ahead in this class, we will be figuring out like in which problem uh, we will be using recursion. Cool, cool. So from here, one take, recursion definition is not only calling function in itself. That is not the only definition. Now, the most important definition for a developer is whenever we are we have a big problem, we will break that big problem into the smaller problems and we will get towards the result, right? That is the meaning of uh, that is the meaning of recursion. So what is the like what I'm trying to say exactly is, so everyone in everyone home there will be a stair, right? Suppose these are the stairs, right? So consider this as a floor and this as a top, right? So here we are we are just stepping down, right? Each and like at a point, single step we will climb up, right? So this is first step, second step, third step, and fourth step. So what was the initial question? We need to reach to the top, but how we are reaching to the top? By taking a smaller step. Once we will we'll step one step, we'll be reaching little top, then second, then third, and then fourth, and then at the top, right? So this is called recursion, right? This is the meaning of recursion. Everyone gets it, right? So we are solving one problem statement. That statement says need to reach to the top, right? So how we will go to the top? By just going one step at a time, right? So that is the meaning of recursion. Any doubt till this point, anyone? Cool then. Uh, Now we will be going into our problem, our first problem, that is recursion. That is factorial, right? We will be okay. Deepak is asking to repeat. So what is I have explained till now? What is the meaning of recursion? So recursion is we get a big problem, and we will break our big problem into the smaller problem to reach to the final result, right? So, what kind of problem it can be? It can be a factorial, it can be a summation, it can be a array sorting, it can be a Fibonacci series. So, anything which have like repetitive step that can be solved using the recursion. Okay. So, how I explain this? So, suppose we need to go to the top, right? By just climbing up the stairs. So we will be taking one step at a time. One step, one step, one step, and one step, right? We are doing same thing on on each and every step. We are climbing up, right? We are repeating. And once we'll repeat the steps each and four times, we'll be reaching to the top. So what we have learned, breaking a bigger problem into the smaller problem, into the n smaller problem. That is the meaning of recursion. Any doubt, Deepak? Cool. We will move ahead and we will learn about factorial n program. We will see how we can calculate the factorial. So I will be I will be telling you both the things. First, we'll be going through for loop. We'll be seeing through the for loop, and then we gonna write our normal program, right? So I just want everyone to write a for loop program to calculate the factorial and send it to me. I will wait for 5 minutes. And then I will be telling you from the recursion how you can calculate the factorial. Okay, so I'm giving you 5 minutes. So please, everyone, please do your code and send it into the chat. Okay. Cool. So I'm stopping my screen for 5 minutes and then again I will share. Okay, fine. So now I got the program from someone who have sent the program. So the Panshu have sent the program, right? Like now many people are sending the program actually. So good. So I will be copying the first program and I will be iterating to you like how it is working. So I have pasted this program here and I am saving it to fact.js. Let's start. Save. So there is some problem with this program, like who has given this, but it's fine. Console log fact. And if I take the number, what is the factorial of 5? 5 factorial is 120, I think. Yeah, it is 120, right? So let me run this program. Let's start. No, this. So I is less than equals to fact, it will be. And then, so this is going into the infinite loop. Can someone say why it is going into the infinite loop? So this should be into the reverse order. This should be into the reverse order. It should be minus minus. It should be starting from fact and should be going till 1. And I should be greater than or equals to 1, right? Right? This is correct, right? Now, if we run this, we got 600. There is again problem, but the previous project was also correct. So can someone fix this particular thing and send it to me again? Because this is not working, right? So if I run this, this is giving 600. So that is not correct. Who can fix this? Okay, let me use Deepak's code. Deepak, I am using your code only, but it is not working, right? This is your code only. See, okay, now I think it should work. It is giving 5. Okay, 120. Yep, it is correct. So what we are doing it, basically it is running I is less than equals to A and I plus plus, and we are calculating fact equals to fact into I, right? So let me copy this program and put it to my tab so that I can explain you. 1 second. Cool. So I got it here. Hmm. Just a second. Give me a few minutes of time, please. Okay, cool. Now we can look this particular program. So what is happening here is we are giving a number 5 and we are creating a for loop. So how for works? For will be this is an incremental loop. This is an incremental loop, right? So when I equals to 1, fact is 1, then what value we will be getting into the fact? Fact equals to 1 into I, 1 into 1, right? This is the step number 1. Step 1, right? Now, step 2 will be when I equals to 2. Then fact value is 1. We will be having 1 into 2, right? And then step 3, when I equals to 3, we'll be having fact equals to 2 into 3, right? So this is how it gonna increase and we will be getting our result, right? It will work for 0. 0, it will not work. We need to put explicit condition to work for a 0. So this won't be working for a 0. So this is just a code which I am trying to explain how for loop is working. Now we will write a program. First, before writing a program, we will read about like PMI. Does people know what is PMI? It will not work. It will not work for 0. Is it so? Yes, Parag. So it will not work for a 0. You can give a try. Okay. So PMI is nothing. It is a concept of mathematics which is called as principle of mathematical induction. Mathematical induction. Okay. So guys, please focus here. And this particular slide is a very important slide. If you get this, you will be getting all the recursion completely, and you will be able to solve like whatever question you want. So this is a very important topic. So whenever we will be in class 6 or 7 or 8, we have read like let us assume x equals to 5 or whatever it is, right? So that is nothing. That is just a principle of mathematical induction. So we will be assuming something and then we'll be going till the result, right? So so for example, if we wanted to uh, this is triangle, right? This is a triangle. Uh, let's consider this right angle triangle is having 60, 60, 60 degree angle, right? This is 60, this is 60, and this is 60. All angles are 60. If the angles are the 60, what we will call this triangle will be what? This is called equilateral triangle, right? Lateral triangle. So now consider we haven't given up this particular value, right? So we will say let us suppose this value is x, right? We'll call this value is x, right? And if we wanted to calculate x, what we will say? 60 plus 60 plus x equals to 180, right? Everyone can recall this, right? Cool. So from this, we can get the value 60, right? So what is we followed 3 steps here. What was the first step? First step is a base case. What is the base case? We assume something. We assume like this angle is a x. Okay. We know certain value of this. Like this is x, right? And then the second case, which is the induction case. What we assume, like we know the sum of a triangle will be 180 only. Sum of a triangle will be 180. It cannot be more, it cannot be less, it will be exact 180, right? So by this, And this is the second case. Sorry, let me make it correct. So this, whatever we know, like sum of a triangle is a 180. This is our induction. We know this. We already know this, right? We already know this. Already know this. So this is step number 2. And what is step number 3? This calculation part is step number 3. The calculation which we are doing to calculate the value of x, it's called the calculation step, right? So base case, self work, recursive call. Correct. So basically, we have a base case where we gonna assume something, or we have a sure short answer for that. Okay, we'll be getting more in a while. We'll be getting more. Just bear with me. Okay. Then we will be writing a recursive function, recursive call, and at the end we'll be writing a logic, right? We'll be writing a logic. So these are the three basic steps which we need to keep in our mind to solve any recursion problem, right? Because this logic, whatever logic we are writing on a line number third, this gonna repeat every time, right? This gonna repeat every time, correct? And this is a recursive call. Recursive call says we need to calculate for all the values of n, right? All the values of n. So this is the meaning of this is the concept called principle of mathematical induction, right? So let us take another example. Let's take another example. Uh, Summation of n. Like what is sigma n? Can someone say? What I know. What is sigma? Sigma n will be like we are saying sum of n numbers, right? Sum of n numbers, right? Where n is greater than 0 and n is like natural number. N is natural number. Okay, cool. So how we'll be proceeding to this problem? First, we will break this particular problem into the smaller part. Okay, this is our step 1. We are breaking our problem into the smaller part. So smaller part. What we can write this as? Can we write this as n plus n minus 1 plus n? Can we write it like this? N minus 1 plus 1 plus n. Cool. We can write it like that, right? And like this, we can break this more, right? N minus 2 plus n minus 1, n minus 3 plus n minus 4. We can do that, correct? All are getting this, right? There is no fancy mathematics. There is no fancy words. This is simple logic which I am telling you, right? So we found something. So suppose if we wanted to calculate sum of 5, okay, someone say sigma of 5. So can we write this as 5 minus 1 plus 4? Conceive n is 5 and sorry, my bad. N is 5. So 5 minus 1 plus 5. We can write this, right? This is correct. Cool. Now, if we will break this more, finally we'll be getting 5 plus 3 plus 4 plus 5, right? We'll be getting this particular thing, right? So here, for every value of I, we are doing something. We are doing something. What we are doing? We are doing this particular thing. For every value of I, we are doing this particular step, right? Right? This is the theoretical thing which I have told you. Now, let's look at a very simple program. First, I am gonna write the program, and then I have actually already written a program, so I am just gonna open that, and then I'm gonna explain you that program. Cool. So, so any confusion till this point to anyone? Okay, cool. Everyone, take a sip of water, and then we'll be again resuming in a minute, in a single minute. Okay, cool. So I have used Sandbox to write the program. This is my personal sandbox where I so recursive factorial. Let's open this factorial program first and see how I have done this, right? So first, I'm gonna explain you this program. So this is a very simple program which we have solved using recursion. Okay. So shall I start? Cool. So see here, this is function called factorial. It is taking a number which is n. We have written a base case, right? So we know whenever n is zero, we will get one, right? Whenever n is zero, we will get one. Uh, like everyone knows, right? How factorial works. Everyone knows, right? So there is no confusion or no doubt. Cool. Now, what recursion we have to do? Factorial n minus 1. N minus 1 meaning every time we'll be decreasing the number. So suppose someone has entered 5, this will be 4, 3, 2, 1, right? Right? And what will be the calculation of this? And this is a calculation part. What calculation we have written? N into n minus 1, right? So you can see here clearly, we are doing same. N into small sum. What is a small sum? Small sum is nothing, but it is factorial of n minus 1. Does this make sense to everyone? Okay. Sum of n numbers. Okay, Deepak, I'm coming back. I'm coming back. Let me complete this. Like you just focus on this particular point, and then I will be explaining you that again. Okay. So we are sending n minus 1 as the argument. Uh, you can say that. You can actually say that, but that is incorrect partially because here we are using n, right? So we are every time we are decreasing it. So, okay, let me dry run this code. Okay, let me dry run this code. Take n equals to 5, right? Consider n equals to 5. Then what will be the value here? 5 is equals to 0? No, it is not equal. It will come here. It will come here, right? Once it will come here, this value will become fact of 4. I'm writing fact just to written in a short. This is fact of 4, right? Now, here, if you will come, what is the value of n? N value is 5. And what is the value of n? My n value is 5, right? So, what this will become? This will become 5 into 4, right? Right or not? So, 5 into 4 is 20. We'll get 20, right? Cool. And we will return an answer called 20, right? So, this is step 1 answer. Step 1 answer. Okay, it works in a very different way, but I am explaining you so that you can get the now n value becomes 4, right? N value becomes 4. So n equals 4 equals to 0? No, it is not. Then how it what this will become? This will become factorial of 3, right? Now if we will be entering 4 here and 4 here, right? Right? But always remember, this is factorial of n minus 1. Factorial of n minus 1. So, factorial of 3, it will be, then what will be this value? This will be 4 into 3, right? 4 into 3 is 12, right? We'll be getting these kinds of values. Are you getting this? This doesn't work like this. I'm going to explain how this works actually. But this is the, like, you need to only remember three things: base case, recursive case, and calculation. Don't question here. Like, don't question here. Like, on line number 5, don't question. This is the power of like mathematical induction. If you have written the logic correct, you will get the correct answer. So here on this step number 5, step number 2, don't question. Simply write whatever the lesser values are. Okay. So this is how principle of, so whenever we assume, right? So suppose x equals to 5 or 4, we never question that particular step, like n equals to 4. We will not do the question. We have a certain things. That is why we are assuming that value. So once, like we will be going through more and more example, this will be very, very simpler for you. Cool. So this is how factorial of n is working. Okay. Let me now run this program. So if I change this value to 6, then we will get 720, which is correct, right? And if we will enter value 0, we'll get 1 because 0 factorial is 1, right? And if we'll enter value, we'll get 2, 3, we'll get 6. So this program is correct, right? So for 1 second, copy sandbox link. Dipanshu, why like question mark? Any problem? It will work now. See, it will work. If you put 1, it will work. How it will work? Consider what is n. N is greater than 0, right? This condition false. 1, let's walk through. Na? N is 1. Factorial of 0. Factorial of 0. This will become what? Factorial of 0, right? Fact 0. This will call fact 0. What is fact 0? Fact 0 is 1. It will return 1, right? You got it, right? Awesome. Awesome. Any doubt in understanding factorial program or any doubt in understanding PMI model? I have shared you the link. Just go through the link and spend 5 minutes with that in understanding the program. I have already shared you the link. Just open that link, click that link, see the program, and try to calculate the steps in your mind. Okay, I'm giving you 5 minutes to do that. Just go through the link whichever I have shared you and just try to get your things. Okay, I'm giving you 5 minutes. They like dry run. I will do a dry run. I will do first. You go through the program. I will do the dry run also. Okay, take Ritik 5 minutes. Do a dry run in your mind, and then I will be doing the dry run of this program. Okay, take please 5 minutes of time. Okay, cool. Okay. So did you guys check the program or not? Okay, cool. Now I'm gonna do dry run of this particular program again. So let me take a screenshot for this. You tell what will be the time complexity of this. Just guess it. O of n. Why it will be O of n? Why it will be open? And cool. Yes, it will be. It it's like, what will the best case of this? What will the complexity in the best case? And what will be that case? And 1 and 0, not 1 or 0, 1 and 0. Be specific. Cool. I am just, give me 1 second. I'm just doing the setting to open this. Wait, just give me 1 second, please. Okay, this is not going. Cool. So we will be doing this particular program here and we'll be working. Okay. So let's start. Consider a factorial of 5. Okay. Factorial of 5. Okay. Now please focus here. This is little important. Are you guys following, right? You guys are following, right? Cool. So, how does this exactly work? This needs to be understood very properly. Okay. So, first we have a value 5. Okay. So, let me make a bucket. Consider this is a bucket, right? Now, in this bucket, what will be our first value? So, consider this is a main function. Main meaning which will return something, right? Now, our first value will be 5. Then we will have 4. Then we will have 3. Then, like, I need to make this bucket big. 2 and 1, right? Right. So now what we are writing here, please understand. First, we are calling small sum, right? Please focus on line number 6. We are calling this particular loop till the time n is greater than 0. Indirectly, n is greater than 0, right? We are calling this particular condition n is greater than 0. So first, the stack will be maintained like this, like 1, 2, 3, 4, and then the calculation will be getting started. So how it will be getting started? First, it will these two values will be getting calculated. Let me write that. So first, we will be getting 2 here, or you can consider 0 also. Okay, we'll be getting 1 here, we'll be getting 1 here, and then we'll be getting 2 here. On the next step, we'll be getting 6. On next, we'll be getting 6 into 4 is 24, and we'll be getting 24 into 120, right? This is how the stack is working, but it is getting stopped till this particular point. First, it will run through the loop, through the recursive call, and then it gonna do the calculation. Why I'm saying that? Because on 6th line, we are writing factorial n minus 1, you call factorial n minus 1, right? So seventh line is executed after line six, right? This line is getting executed after line this. So we are saying first you make the star and then you do the calculation. So once the value is zero, the one will be returned. So this is here. Now the value will become 2. Then 1 into 2, we will be getting this value, and this value, and the last value. So any confusion in this particular understanding, like how the factorial will work, like what people used to think, people will be thinking, first we'll be doing this calculation, then this, and then we'll be going to the result. So that is a hypothetical thing, but actual under the hood, this particular thing is happening. And this bucket, whatever I have created, this will be called as call stack. If you have heard this name before, I'm not sure, but this is called as a call stack. Okay, and then it will be returning us the value. So how I can prove this? So let's do one quick thing. Let's understand this. Console.log, we'll say answer. So please see here carefully what we are getting. Let me clear this console and then rerun again so that you can clearly see. Okay, cool. So let me, oh shit, sorry, my bad. Cool. So 1, 2, 6, 6, right? So this is how it is working. This is how this particular thing is working. Okay. So I hope you are getting how the recursion works actually, and what is the meaning of mathematical induction, right? Now, someone, are you guys getting it or not? Please tell me honestly. Otherwise, I will be repeating it again. Okay, I don't have any problem, but there shouldn't be any doubt in understanding. Okay, why? Just a sec. Why it is not working? Any doubt to anyone at any stage? We have a plenty of questions, and few I will be giving to you, and few I will be solving with you. Okay, cool. Shall I move ahead? Yes, Fibonacci is a next program which we're gonna do. But before that, so Fibonacci I will be doing. But before that, I want you people, because you already understood the concept of recursion, you already read in the before past classes. So I want you should just give a try. Take 10 minutes of time and give a try. Whatever base case, recursive case, and the calculation part, you just give a try. Whether it is a wrong or right doesn't matter. You just give a try, and then I will be explaining you the Fibonacci step by step, by call stack, everything I will be taking care. Okay. So can are you guys interested in solving the question, or shall I go and show you the question? Please comment. Please, interested. Okay, cool. So here I will be giving you. So time is 8:47. Uh, we'll be again resuming at 9. I'm not going anywhere. I'm just sitting here. If anyone is taking at any place, ping me. Okay. I'm just turning off my camera, and I'm just giving you 10 minutes to solve this. Cool. Okay, so Dipanshu have solved this. Anyone else? Ekta is factorial of number. Fiblokai. Okay. Factorial. Why you are solving factorial of number? We have asked like this one, like Fiblokai series, which he has done. Okay, no problem. Start using return instead of console.log, guys. Like, don't use console.log. Please use like return statements and give a proper naming convention. Right now, it's been a while here. You are learning this, so be little generous to this. Okay, for people. 1 second. Why you have used for loop, dude? What is the need of for loop? Uh, no, this is not correct. This is not correct. No, 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 no. Dipanshu, your solution is not correct, dude. Like you did something wrong. Manoj, you are trying to speak something. Okay. Uh, but it's my humble request to everyone. 1 second. Nishant, I haven't seen your code. Sorry. Where is your code? Ekta, Ravina. Okay, so many guys have did. Oh, nice. This is nice. So let me go through each and every program. Okay, I'm starting from uh, function. Mm. I'm starting from the Nishant. Nishant has done good job. Nishant program seems to be correct. I'm just gonna copy and paste it here so that everyone can see this. His program is absolutely right. he has written a FIBO function. He has written properly the base case, properly the recursive call, and the logic, right? So he has written everything correct. So his program is correct. Well, like good work, Nishan. And then I will come to Ritik. Ritik seems to be wrong here. 1 second, I have copied Ritik, and this is FIBO. Okay, FIBO, he is doing FIBO n minus 1, n minus 2, I equals to. Yeah, Ritik is also right. Ritik program is correct. Ritik program is correct. Parag is also right. But I am not sure why you guys are writing for loop. We are not allowed to use any for loop and while loop today. Okay, only you need to write a recursive function. No for loop is allowed. Okay, so I think most of the guys have done the like program nicely, and they have written a correct code. Uh, like it will make series. No, series you can make it from the recursive also. For loop is nothing. It's just a recursive function which you are using at the moment. It is nothing else. So basically, our goal should be we shouldn't use for loop. We should use the recursive function whatever we have created. Okay, so what you are learning here is in today's class, you are learning how for loop is written, how while loop is written, how do while loop is written. That is the only intention for this particular class, right? So don't from now and for any problem, nobody is allowed to use for loop or while loop. Okay, but I am really happy. Like many people have solved program correctly. uh, like I'm not sure like when I have explained from there or from the past, you know this recursive concept, but it is nice. I am very much happy. Like you people have done the good job. Okay, so I just wanted to everybody. Cool, cool. I will. I. It is simple, Parag. Don't ask. Uh, okay, you can ask silly questions, but you have learned this, right? So if you wanted to print a series, right, what is your goal? You wanted to print a number from 1 to 10. That you wanted to do. You wanted to print number like this: 1, 2, 3, 4, 5, 6, 7. Like this, you wanted to print a number. That is a use case. Zero. Okay, series. That is not the that is not the problem statement. Problem statement was you need to print a sum of the Fibonacci series. Sorry, that's my bad. I haven't told you, but that was the intention to write a sum of the Fibonacci series. Okay. So simply printing, Ekta Kumari, like what you are writing, simply printing will do the job, but it will not do the job which needs to be done, right? So basically, whatever output we are giving from the function, it should be from the return statement. It should be from the return statement. You can do one thing, you can push elements to the array, and at the end, you can return the array. That you can do. Okay, you can try for that. But you are not allowed to console.log. You need to return everything at the end. Are you guys getting it? So whenever we are writing something, so suppose this is a Fibonacci series, right? So this is n equals to 1. We can push the values to the array. So consider this array, let array equals to whatever. And then we can push this. Like we can say array dot push this value, whatever comes from here, and then we can return the array, return ARR. You can try this kind of stuff. Okay. So here you will see lots of problem. You need to fix this problem. This we gonna learn little later, not now. This we gonna learn little later. But you need to use something like this if you wanted to use a loop or something. So Nilanjan, for loop shouldn't be used because today we are reading about recursion. We are not reading about for loop or the while loop. So a recursion is a topic which is self-calling function. We need to solve everything from that. We shouldn't use for loop today. You can print Fibonacci series using the recursion. So Deepak, that's what I am telling. Yes, call stack we are going to make. Wait, Riaz, have you solved the question? Like first, have you tried to solve the question? Okay, where is, can you please paste it again? Can you please paste it again because it is went up. Can you paste it again, please? Okay, cool, cool, cool. So let's go through our program now and see how we have done, right? Let me click it here. This is factorial, this is sorted, where it is. I think I haven't done. Let me do it very quickly. Create a sandbox, vanilla JS. Cool. I'm just gonna write that program very quickly. So what we need to write, what is our function should be called? We can call our function as a const Fibonacci, and don't go to the spelling. Spelling is wrong. I know. What it will take? It will take a integer which is n, and for safety we will put a value called 0 by default value, and then uh, how this works, we will write base case first. Base case, we will write base case first. Base case says if n equals to what, n equals to 0 or n equals to 1, then we should return 1. Correct or not? Our base case is correct or not? What is wrong here? Dipanshu, what is wrong here? Good catch. So we should return n here, right? But now Dipanshu understand what we are saying, n equals to 0 and n equals to 1. If we wanted to, for everyone, if we wanted to return 0 and 1 from here, either we split our loop in two parts, loop in two parts, n equal 1, then return 1. Okay, either you return n. Whatever seems fine to you, you can use that. Okay, so this is a base case. We have written the base case. Now, what is Fibonacci? Fibonacci is nothing but it is a sum of last two numbers, right? So 1, comma 2, comma 3, comma 4, comma 5. So basically 5 plus 4 plus 3 plus 2 plus 1. This is called a this, right? So we will write let small SMALL output 1. What we will write it here? Please say what we will write it here. And we will put let small output 2. Please fill both the values. Everyone, please fill both the values. Fibonacci of n minus 1 and Fibonacci of n minus 2. Very nice. So we will write Fibonacci of n minus 1, and here we will write Fibonacci of n minus 2. Make sense? And what we will return from here? What we will return from here? The sum. Small and small output, right? Right? Now let us test this. Console.log Fibonacci of pi. So our output is not coming correct. What mistake we have done? our output is not coming correct, right? You can see down here it shows 5. Here it shows 5, right? 1 second. Add before written. Please give me the logic why we should add before the written. Like why we shouldn't do this. Can someone give me the logic for this? Anyone? Written will terminate. We are not storing the previous value. Okay, so this is the previous value, right? N minus 1, n minus 2, and we are doing this. So it should be, we are we are doing one mistake. I need correct thing. Like, please give me the correct thing. So let's go to the basics. Let's go to the basics. Let me go to the notepad. This is our notepad, right? Where is notepad went? Chat. Let me open chat. Cool. So let me open the Fibonacci which I have written. 1 second. This is called call stack. This I have explained already. Just give me a sec, please. Okay, cool. So now we will see this particular. So this is a Fibonacci series, right? 0, 1, 1, 2, 3, 5, 8, 18. What is Fibonacci? Fibonacci is nothing, but it is a sum of last two numbers, right? It is a sum of last two. So we will create three cases here. First is a base case. What base case will do? If n equals to 0, we will return 0. First simple case, if n equals to 0, we will return 0. Now we are assuming this. So let the small output is this, and let the this output is this, right? And then we are saying return small plus output 2, right? So I have written here error because of base condition. Error is given because of base condition. So what is we are missing in the base condition? Is my screen is visible? Equals to 1, right? So now again I will go back to this screen. So here we have written 0, here we have written 1, here we have written small value, and here we have written this. Now we are calling Fibonacci equals to this. So now our output should be correct. Why it is not coming correct? 1 second, return. So consider now we will dry run. Now we will dry run our code. Okay. We should take n equals to n minus 1 to get 3. N equals to 1 second. Just give me 1 second. I have done some mistake. I'm not sure where, but surely I've done some mistake. And small output 1, small output 2, n equals to this. Now this is the base case. This is the recursion, and this is the logic. Okay. Fibonacci of 6 is what? 6 is okay. And 7 is 1 second. N equals to it's correct. Is it? Just a sec. Just a sec. Yeah, it is correct. Uh yes, it is correct. It is correct. Sorry, my mistake. My mistake. So it is saying small output 1. Yes, it is correct. So I was in different zone. I was thinking the sum of last two. Sorry, my bad. So whenever we are entering the 6, we should get 8. Yes, it is correct. 5, 8. Yeah, it is correct. So my bad. My bad. Okay. Remove the fourth line and write return 1 equals to 0. What the fourth line? No, it is correct. We can actually this line is not even required. Okay, we can delete this line. But this will make this program to go into the infinite loop, right? So why it is going in infinite loop? Can someone give the answer? So this is saying maximum call stack size exceeded. Uh, like what is the reason it is going into the maximum call, like maximum call stack size? Yes, whenever the value is one, it will be going to the minus one. So we can do like this also, right? If n equals to this, and we can do like this also, right? This makes sense. N is if n is greater than n is less than or equals to zero, n is less than or equals to zero, return n is less than or equals to zero. No, this is also not correct. If this is the value, then it gonna again fit. So we need to use this condition only. We need to use this condition only. Okay. I think now it is correct. So let's dry run this program again because there was a little confusion. So let's dry run this program. Okay, cool. So this is we are here. Let me delete few portion. Cool. So at the bottom, we will say main, right? At the bottom, we will say main. Now, what is the value of n? We are saying 5, right? What is the value of n? We are saying 5, right? So what will be the first value here? Whenever first value will be 5, right? Fibonacci series, it just like you are making your logic strong. And actually, we do use Fibonacci series, like where we need to do sum of last two numbers which are coming. Actually, we do use Fibonacci series is important, and we do use. Okay, so it's basically you are making the fundamental strong. Like I got humble, right? Because I haven't realized like what we are doing. So I thought when we are entering five, we should get some bigger number. So that was my perception. So I got little mistaken. Even like PMI will make sure if our logic, if our calculation, if our this line is written correct, we will get a correct answer. If our this line is written correct, we will get a correct answer. If our calculation and recursion, these two things are written correct, we will surely get our correct answer, right? So let's dry run, especially Riyaz, please focus. So first value is 5. Once we have written 5, what we will get? We will get here small output 1 will be Fibonacci of 5 minus 1, which is 4, and Fibonacci of 3, right? So this is a small output 1 and this is a small output 2. Okay. So what we will get? Fibonacci of 4 and Fibonacci of 3. Now again we'll go one more step ahead. It will be 4. Then we will be getting Fibonacci of 4 minus 1, 3 and 4 minus 2, 2. Right? This is how it gonna progress. 3 Fibonacci of 3 minus 1, 2 and Fibonacci of 3 minus 2, 1. Right? And similarly goes for 2 and similarly goes for 1, right? And similarly goes for 0 because we have 0 also. So this is how the call stack will be looks like, and at every step we will be having a different values. So any confusion in, I know like I have confused a little bit, but I hope you got the gist, like because many people have solved the problem. So I have created the confusion by taking the value 5, but I hope people have got the logic, like how it is working, right? Can someone say yes or no? I wanted to hear from those who haven't got. In box 4, why we are not writing F3? We are not. We have written F3 here. We have written F3. So let me zoom it. So this is F3. This is nothing but this is F3. Cool. Now we will be solving one very interesting problem, which like you might all knowing. We'll be calculating the powers. So uh, x to the power any number m maybe. So I have told you about the Likit printing the series. Like printing the series, either you push into the array and return at the last. You can do that particular thing. Okay, or you can do the console.log. What to push? The output, the result which you are getting, you need to push that. Okay, I will solve that particular thing. Let's do it now. No, first we'll focus on x to the power n. Like I have a couple of set of problems for you, and then I will be telling you how you can print, or we will be doing in this one. We'll be printing the series. Okay, cool. So here we have a simple thing which where we need to print x to the power n. So what is x to the power 5? It will be 4, 3, 2, and 1, right? Right or not? We'll get ones. Look at, we'll take care of that later. Please bear with me. We'll be doing like in this one, we'll be printing n or we'll be printing series. Then I will show you the next problem, how difficult it is. And then we will be gonna do this particular problem after this. In this, we're gonna print the series. Okay, this particular problem, which I'm highlighting. Here we will try to print the series. Okay. I haven't prepared for the series, so that is why I am not printing because I need to write the code for that. So I will give you one problem. I will write the code and then I will walk through you about that. Okay. So first focus on one problem, which is x to the power n. Okay. Power of x to the power n. Okay. So if you wanted to calculate 5 to the power 4, how you can write this? You can write this like this, right? 5 into 5 into 5 into 5, right? Right? This is how you can get the result of 5 to the power 4, right? And also we can do like this, 5 into 5 to the power 4. This is also same, right? So here, here we are going to solve the same thing. Here we gonna solve the same thing. So let me make it clear for everyone. Our problem statement is we wanted to print x to the power n. For example, if we wanted to print 5 to the power 4, then how we can do? We can do 5 to the power 4 minus 1 into 5, right? Then this will become 5 minus 3 into 5, right? Again, this is a recursive chain. 5, we can write it again, we can break down this, right? So this is a particular problem statement. So please try by your own for 5 minutes and then we'll be solving this particular problem. Okay, I am also gonna solve this time with you. So you can see my screen for those who are not getting, and rest can solve the problem. Okay, those who are comfortable, they can solve. Rest can see my screen, how we are planning this particular problem. Okay. I am solving this problem for everyone, but if you wanted to give a try, you can try by your own self also. Okay. So I have given the logic you can think of. So first, whenever we wanted to calculate the power, we gonna just for your reference, you can use this particular function, uh, maths.pow. Okay, math.pow. You can use which will be helping you in getting the power. Okay, you can use this particular function. This is for your reference. You can use this particular function. Cool. Let's focus on the program now. So we will be writing our function const power of x equals to. We'll be taking two numbers here. First will be x, and then will be n. So basically, this will be nothing, but it will be looks like 5 to the power 5 to the power 5 power 4 or whatever. Okay. People are trying, right? Dipanshu is very fast. Dipanshu has done the code already. Power index base power 1. Uh, okay, but n into power. Uh, okay, cool. X minus 1 and 4. Cool. So Sharad has also done any other. So we will write. So first, if n equal 0, we will return 1. Why we will return 1? Because if 4 to the power 0, we'll get 1, right? So that is why we are returning. This is called as a base case. Okay, right? And then another base case looks like n equal 1, we will return n. Sorry, if n equal 1, then we will return x. Okay, so x is the number and n is the power. Cool. So these two are the base case. Base case 1 and base case 2. Right? Any problem till this point? Cool. Now we will write our records. Why return x? Why return x? X is nothing but the number. So 4 to the power 1 will be 4, right? That is why we are returning x. We are returning the number itself, nothing else. Suraj, does this answer your question? Then we will write one question, small sum equals to power of x. Here what we will write, x minus n minus 1, right? And at the end, we will return x into small sum. Does this make sense to everyone? Does this make sense? What is not needed? I am not getting. Look at your line number 5. Line number 5 is not needed, but you should do the practice to write all the base cases. Okay, you should do that kind of practice so that you can get all the base cases. So console.log power of x 2 comma 2. What answer we should get? 4, right? 2 comma 4. What answer we should get? 16, right? So people are pointing to the line number 5, but we should write down all the base cases in solving the initial problem. So base cases. This is what? This is the recursion, right? Recursion, right? And here we will be having what? We'll be having a calculation. Calculation. Now let me try one thing. If I can do that for you. Const will be solving. Let array equals to 5. Yes, we'll take a break. We'll take a break. Right. Wait for a second. So everyone got this particular problem, or you people, anyone is having doubt? Does anyone having any doubt? Cool. Then then we will be taking a break for 15 minutes, and post that we'll be looking into the problems of printing the series. Okay, printing the series. Cool. Okay, we'll be meeting at 9:45. Suraj, you are asking about how call stack will work in which question? Like the one which we solved just now, the power one? Hello, is I'm not audible? Okay. I'm asking, shall we resume now? I think people are back, right? Cool. So I have written a small program before going to the big program. So here we'll be seeing like how we can print the numbers. Okay. So if I will enter something like console dot log print screen. Oh, sorry.
print series from 5, 4, we should get a 1, 2, 3, 4, right? This is how we can do. Now, I was suggesting to have a array, right? So, what is the meaning of array and how we can do that? Let uh, input numbers equals to this, and we can do input numbers dot push, and here we can print those numbers. So we need to call this stop, and then we need to print the numbers. Okay, so this is how we can console.log. If we wanted to use, we can use console.log here. And if we wanted to print into the like into the console, then we can use this particular thing. Now, is this clear to everyone? First of all, like how we can use recursion to print the numbers, is it is simple. It is extremely simple. Now, like I will be covering two more questions today, which will be little high level questions, and then I will be revising you this recursion whole. uh, Call stack will work. Call stack will be working same way. I will suggest you just draw that bucket and try to put the values of n, uh, and then I can say you if you will struggling there. So it will be working same way as the previous you haven't got. Okay, then let me explain you. Then let me explain you. Okay, so just give me a 1 second. I am gonna share this. Cool. This is the number, right? So, how we have designed that our earlier thing, like if we are writing 5 to the power 4, what we said, like it will be 5 to the power 4 minus 1, right? Like this, we have decreased the power. So, call stack will be, so this will be a main. At this moment, I'm not writing main. So, first, we'll be calculating 5 to the power 4, and then we'll be going 5 to the power 3, 5 to power 2, and 5 to the power 1. Okay, this is the like, then how this calculation will work, that will be working from the like addition. The values will be getting added and added and added. We have written the same logic, right? 1 second, where is x? Here, right? So call stack will be working like, will be 5 into 4. 4 times 5 will be here, 3 times, 2 times, and 1 time. Simple. Okay. So I think another question again involves uh, power. So let's first see the question, and then if the this power thing is not clear, then I am gonna explain you again that power thing. Okay, how it is working. So next question says, uh, let me go. Okay, let me add a new page. So now we will be creating a series. How the series will work? Series will looks like this. 2 to the power n. So we need to do this particular thing. 1 upon 2 to the power n. So how it will be? It will be 2 to the power 0 plus 1 upon 2 to the power 1 plus 1 upon 2 to the power 2 till 1 upon 2 to the power n minus 1 plus 1 upon 2 to the power n. Okay, it is a simple thing, but you need to be you need to be you will be focusing on three cases. First is the base case, right? Let me turn on my camera. I think it stopped. First, we will focus on the base case, right? What is the base case here? Here, base case is when n is equals to 0. This is the first thing, right? When n is equals to 0, we know what will be the value of this, right? And consider this only as a base case for now. Okay, consider this only as the base case. So what will be the value for the base case? It will be 1 upon 2 to the power 0 what is the value of 2 to the power 0? It is 1, right? 1 upon 1 equals to 1, right? So if we are entering n equals to 0, what output we'll be getting? We'll be getting 1, correct or not? Cool. So now I will ask everyone to comment, to write in a chat, what is the recursive case of this? What is the recursive case of this? Okay. I will ask everyone to write the recursive case of this. People have written or not? Just a sec. Series 1 divided by n minus 1. Series divided n minus 1. Okay. Anyone else is trying? Or no. This is only we are printing the result. For now, we are printing the result. If n value is 5, we're gonna print the result. Okay, Dipanshu? And then we will try to print the series. Then we will try, because okay, so we need to solve the series. We this series is there, right? 1 second, let me go to my screen again back. So we need to solve this series. So six summation always says we will give summation, meaning we will give the value of n and I need the sum. So for example, if n is 2, then our series will be working till here. So what will be the output? Output will be 1 plus 1 by 2 plus 1 by 4, right? Now we can calculate this. 4 plus 2 plus 1. 7 by 4 should be our answer. Okay. This result we should get. One. Okay. Okay. Can people will be little active so that I want like recursive case from many people, like at least 2 to 3 people can more if answer, then it will be nice. I think no one is going to answer. Okay, no problem. So you can clearly see that recursive case is always n minus 1, right? So can't we write like this? Let sum equals to whatever it is, g sum. It is called geometry sum actually, n minus 1. This is the recursive case. That's it. Like, I don't know why people are you guys not getting, like, if you're not getting, I can explain you this thing from the starting again. But like recursive case, like you should. Okay, Deepa. Okay, so take 5 minutes of time and try by your own self. Take 5 minutes of time and try by your own self, Deepanshu. Okay, if anyone is struggling, they can ask for the help. I have seen people are not asking for the help in the like whatever I am teaching. Like they are going somewhere else. So like my assumption is like you have solved the problem of Ibn by your own self. You have given the answer for. Okay, fine. So basically, you need to print the sum of this particular series, right? A sigma summation of 1 divided by 2 to the power n. Okay, this sum series you need to print it up. So how we can write this series? We can write this series like this. We can write this series like, no, I am just explaining the question to Hariharan, nothing else. So we need to write the sum of this particular series. This series goes like this. N value will be starting from 0 and going till n. So 1 divided by 2 to the power 0, 1 divided by 2 to the power 1. Like this it is going. Okay. So you need to give me the code for this. I'm just writing this program because I haven't solved. So people, please, like who are solving, please focus on their screen, and those who are not getting can see my screen. So first, we will take an input called like whatever the um, n will be. So instead of writing k, let's put n, and then we will write the base case. We will write the base case. So what is the base case here? Base case is if n equal 0, we can return 1, right? We can return 1 directly. And what is the recursive case here? We can say let small answer equals to g sum minus k minus 1, or we can say n minus 1. Okay. And then we will do the calculation. What we can return? We can return small answer plus 1 point or 1 divided by math.pow to the power 2 comma n. So that's it. Okay. Uh, did someone able to complete the question? Did someone able to complete the question? No, sir. Okay. So again, I am gonna explain the question again to everyone. So we are writing summation of 1 upon 2 to the power n. Okay. So how this will looks like, where n is greater than 0 and n is less than n. Okay. So how this will looks like, this will be 1 upon 2 to the power 0 plus 1 upon 2 to the power 1 plus 1 upon 2 to the power 2 till 1 upon 2 to the power n minus 1 plus 1 upon 2 to the power n, right? So here, this is the base case, right? This is the base case. This is the first value we know. We already know. Like if we will input n equals to 1, we will be getting output as 1. And what is the recursive case? Recursive case is like consider this as a G sum. I am calling at a G sum because it is a geometry sum. So we can say G sum equals to n minus 1, right? Because this is the recursive step here. This is the recursive step. And we doesn't have to question. Why? Because it is going till n minus 1, right? So that is why we are writing a recursion of G sum n minus 1, right? And once whatever the output we will be getting here, we can add that. It's very simple logic. So if you will see the code, it's a 3-line code. So what we have done, we have calculated, this is the recursion we have written, and then we have written the simple calculation. Whatever we have, I have said this, right? 1 divided by 2 to the power n, right? 2 to the power n. So if you will see the code, I have written the same thing. This is the calculation step, right? Small sum, whatever the output is coming from the top, add this particular number, right? So this is called n minus 1 plus n, right? So it is simple. 1 upon 2 to the power n minus 1 plus 1 upon 2 to the power n. You have to remember this particular calculation. You have to return this particular thing. This is your answer. If you will put value of n, you will get the logic. Doesn't care about what you're writing till here. Do not care about, oh sorry, do not care about the middle part. You have to care about two parts. First part should be, let me change the color of pen so that first part should be your base case, which is first value, and the second part will be the recursion part, which is last two values. And you are doing same thing. This is the recursion step. N minus 1 is the recursion step, and n minus 1 plus n is your answer. So if you see this particular program here, I am doing the same thing. Recursion step is what? N minus 1. This is our recursive step. And do not question this step. Like this, we are assuming. This is our, but we cannot question this question. And this is our logic. Small answer plus 1 upon math.pow 2 ki power n, whatever we are doing. It's actually simple. Like if you are not getting, please let me know. I will be explaining you with more simpler problem statement. But be honest, like you are not getting, meaning you are not getting. Please say yes or no. Okay, fine. So let me explain this problem first, like from the basic, and then I will give the input 3. Okay. So before, like I am now I'm getting you people are getting confused. So let me go step back. No problem, no problem. I will explain. I will explain and I will repeat. No problem. Okay. But my only goal is you guys should know everything. Like you guys should know the logic. That is my intention. So now forget this series. Like forget this series for a while. Okay. Just cut it. Think about summation of n. Okay. Think about summation of n. Everyone can think about this, right? Wait, Dipanshu. First, you understand again, like whatever I'm trying to explain, then you can solve the bigger question. Okay. What is sigma n? Sigma n is nothing but it is plus 2 plus 3 plus 4. Okay. And it will be going till n minus 1 into, sorry, plus n, right? This is the sigma n. Everyone agrees till this point or any doubt? Cool. So now I need to begin this value from the 0. Okay. Sorry. So now what is the base case? What is the base case? Base case are the few first values. Always note base case is few first values. So here, what is the base case? Consider the base case as first value. You can consider two value also. You can consider three value also. There is no problem. But for example, for now, just consider these two values as a base case. Okay. For now, consider these two values as a base case. Okay. So let me write it down here. Base case. What is base case? If n equal 0, we will return 0. Agree from this line or not? Cool. What will be our second base case? N equal 1, return 1. Return 1, sorry. Any doubt on second line? Any doubt? Okay. Now, please focus here. Now I am gonna write recursive. Let me write it with a different color so that you people are not getting confused. Now here recursive. What is recursion case here? Let small sum equals to consider I am calling it as a sum, function sum. Okay. What we will call sum equals to n minus 1. Right? This is the recursion. Right? We will be repeating till which step? We'll be repeating till n minus 1 step. Right? We'll be repeating till n minus 1 step. Agree or not? Correct? Cool. Now, what will be the answer? What will be the answer of this line? Answer will be, or you can write it as a calculation also. Answer will be nothing but sum of n plus small sum. Small sum. Agree or not? And what is the sum of n? It is nothing but the value called n, right? So I can replace this sum of n with n. Correct? Correct or not? Any confusion in understanding this particular program? No, right? Everyone agrees, like people got understanding of this program very clearly. Awesome. So now just say me one thing. Now say me one thing. If I put if I change this program to little different program like sigma of 1 upon n, sigma of 1 upon n, then what it will be? 1 upon 0. So here n should be greater than 1 because 1 upon 0 is infinite. So please make a note of this. It should be n should be greater than 1, greater than equals to 1. But I am just explaining you. Okay, I'm just explaining you. So I'm writing 0 here. Okay, I'm just explaining you. So don't question like why you are writing 1 by 0. So 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3 till 1 upon n minus 1 plus 1 upon n. So you can write this equation very clearly. You can write this program very clearly now or not. Everyone, this is nothing. This is simple. Whatever we have studied one step before, right? Only what we did, we just added, we have to write this. That's it. Our program is done, right? 1 upon n minus 1. That's it. Only this much change required, right? Now, if I will say, we have to write sigma of 1 upon x to the power n. Sigma of 1 upon x to the power x to the power n. Then you can write this program, consider x equals to 2. So wait, let me delete this x also and make it as a constant called 2. Now you people can write this also, right? What this will be 2 upon 1 or 0, 1, 2 to power 2, 2 to the power, and this will be 1 upon 2 to the power n minus 1 plus 1 upon 2 to the power n. If you can write this particular program, then why you people can't write this particular program? Now you have a confidence to write this program or not? Everyone. Cool. Then I will give 3 minutes. Like seriously, this time I'm gonna give only 3 minutes and you have to write this program. And I'm starting the timer also. Only 3 minutes you guys have. Okay? Only 3 minutes. And please submit answer with 100% honesty. If you are not getting, I am ready to explain it again, but please be honest in writing the program. Okay, brutal honest you have to be in writing the program. Okay. Checking. I'm just checking the Panchu. So basically, sum mini, you are writing if n equals to 0, return 1, base condition, sum mini equals to 1 divided by 2 to the power 2 to the power decrement n minus 1, return sum mini plus 1, 2 divided by this. Okay. So why you are not using math.pow instead of double star? Console.log. We will enter value called 3. Someone was asking to enter value 3, right? GSUM. Okay. We got 1.875. Does everyone is getting same answer? 1.875? Does everyone is getting same answer? I'm just trying to debug the Dipanshu's code now. It looks like it's correct, but let me debug this. So he said let sum equals to this const decrement maximum call stack of size 1. Okay, so you are missing n equals to 0, return 1, recursive call. Oh, this is the mistake, dude. Here you need to only call the code, right? So you are calling decrement, right? So it should be n minus 1. That's it. Okay, here it should be n minus 1. Now you are again decrement. 1 second, let me close this timer first. Okay. N equals to 0. And return sum plus sum mini plus 1 divided by, this is again wrong, right? So it should be math dot pow 2 to the power n. Now you should get the correct answer if I enter 3. Yes. So Dipanshu, have you got the mistake? So see, Dipanshu, please see carefully what you are doing here. You are just uh, you this is wrong, right? If you will call this, it will be keep on calling and calling. Here, this is the calculation step. You need to calculate. This is the calculation part, dude. You need to calculate this sum of math. Cool. I think now everybody have the confidence in the recursion. So I would like to ask everyone to practice more and more questions. I am gonna I am gonna give you set of the questions, and I'm so sorry. Like I have confused a bit in our Fibonacci series. That is like I got like confused in that. So but I am so sorry for that. So now recursion part is not yet finished. What is not working? Why this is not working? Okay, let me check. Function. So see, let's see your code. What you are doing here, this, where is your recursive step? Where is your recursion step? Likit, you haven't given the recursion step, right? Power is n minus 1. This is result is not defined. Where is result? Let. Now it will work. So two mistake you did. Okay. Any other whose code is not working and want me to understand, want me to look at the code? Any other guy? Any other people? Okay, where is Deepak's code? I wanted to look at the Riaz code as well because he Deepak, where is your code? Okay, cool. So fourth. N1 maths power. Your is correct only now. Then your code is not correct. Sum, small sum equals to g sum n minus 1 and maths power to the power. So Deepak, I fixed your program. I hope you have saw, like, you have written two bad conditions. First, what is the base condition I told you in that program? Base condition is of 0, and what will be the output in base condition? Output will be 1. So you have to write 1 here. And this condition shouldn't be there, right? So if you are writing n equals to 1, then what will be? It will be 0.5. Here the answer will be 0.5. So you need to delete this particular condition and you need to write only one condition, which is base. This is your base, right? So check the answer. So you are doing the same mistake. Ekta, you are doing the same. This is Deepak. Got it. Return equals to 0 and it's some. I think your is correct, right? Your program is correct. Function S. And peoples, you are not running your program, it seems. You are just putting. So this is fine. Nth is sum n minus 1, correct? Your is correct, right, Ekta? Then your program is correct, Ekta. I'm happy that you people are like solving the program. So just a honest feedback from everyone, like how confident you are with the recursion. Like everyone, please answer everyone. Like how much confident you are. Riaz, this is your program. Uh, please see the screen. What? Why you have written if n equals to 0? Why you are taking rest on the top? This is wrong. You shouldn't take rest on the top first of all. And why you are writing this n equals to n? What is Riaz? This is not correct. Oh, very bad. Need practice. Yes, you need a practice. No, you doesn't need a practice on complex question. I am gonna repeat again because many people have done the mistake. I'm gonna repeat the first question itself to you. Okay, so please again focus on the screen, everyone. This is my humble request to everyone. Please focus on the screen. Until and unless you will not become strong in recursion, I won't be moving ahead. So again, please focus on my screen. Just a sec. Where is my pen? Give me 1 second. I lost my pen somewhere. Yeah, got it. Okay, now this is again I am going to explain uh, with basic to the normal, basic to the complex problem. So please focus again. Okay, everyone, whatever you are doing, stop and see my screen. Okay, everyone, please see my screen. So in recursion, we only focus on three things. First thing is, first thing is we will find our base case. Second thing is we will be finding the recursion, like recursing step, or in simple word, repeating step. And third, we will do calculation. So you got the logic of recursion, okay, but your you are not able to calculate mathematically. You are just rushing to solve the problem. Don't rush. Okay, these are the three basic requirements which we need to pull out from the question, from the any question. These are the three basic requirements: first, base case, recursing step, and the calculation. These are the three basic requirements. Okay, now we will see how to approach these problems. So now let's take a sum of n numbers again. This is I am taking because I have explained this so many times. Okay, now what is summation of 1 0 plus 1 plus 2 till n minus 1 plus n. This is the summation, right? Now, what is base case? Base case is generally first or second value of our equation. What is first value here? 0. And what is second value here? 1. So we will write base case for first value. Why we will not write base case for the second value? Because we doesn't see any gap between second and third value. What do you mean by that? So uh, no, I will not explain that now because again you will get confused. So we will write first case. We will only take care of first case. Okay. So what will be the first case here? If n equal 0, we will return n. Always remember we will be returning constant value here. Please never write return n plus 1. No. So so this first step says you are sure, here you are sure what is the result. What is the result? Okay. In first step, you are sure what is the result. So you will return always the result. Okay. You will return always the result. Always remember, you will be returning always the result. Okay. You never gonna return n or something. Okay. What is the base case? Base case is the constant which answer you already know. Okay. Cool. Any clear, any doubt in writing the base case? Cool. So now we will be writing couple of base cases only. We are not going to write the recursive. We gonna write a base case only. So consider a problem statement which says n sigma n of cube. Okay. This is a cube. Okay. So what will be the 0 cube plus 1 cube plus 2 cube plus 3 cube plus n minus 1 cube and n cube plus n cube. So what is the base? What is the base? Here base is this particular thing, right? If n equals to 0, we will say what is the output? Any power 0 is what? 0, right? Any power 0 is 0, right? Correct? So now you think of this way. If you have included this in your summation, consider if this is a multiplication, right? If this is a multiplication list, everything will become 0. So for 0, we can calculate the answer, right? And same way, we can calculate the answer for 1. What is, and if n equals to 1, what will be the output? It will be 1, right? 1 to the power anything will be 1, correct? Correct or not? So these two are the base cases. But now you try to give 2 as a base case. Consider 2 as a base case. Okay. So if n equals to 2, it will be not 2. What it will be 2 into 2 into 2. So see, this particular step involves a calculation, right? We need to do some computation here, right? So we cannot make this particular case as a base case. Remember, we cannot make this case as a base case. Why? Because here we are doing calculation. You got it? Cool. So I am gonna delete this particular thing. Right? So what will be our recursive? Now? Recursive will be what? N minus 1 ka cube. Simple. This will be the recursive, right? Cool. Now what will be our return? Return will be what? N cube plus small. Right or not? Any problem in writing this? All the cases? Any problem in writing these cases? Okay. Now we will go to the complex problem. Now consider 1 upon n minus 1 power 3. This is very complex, right? Right? So what will be the first value? 0 minus 1 ka cube. Right? 0 minus 1 ka cube. Plus 1 upon 1 minus 1 ka cube. Plus 1 upon 2 minus 1 ka cube. Okay? Till what? 1 upon n minus 1 ka cube plus 1 upon n minus 1 ka cube. Very big equation, right? Right? Now, we will get one more condition here where n is greater than 2. N is greater than 1. Why we will get these two conditions? Because if it is 0, if it is 1, it will be infinite, right? It will be infinite, right? So we'll be getting one more condition. So in that case, we gonna delete this, right? We gonna delete this. So now please understand our base cases. So what will be our base case? If n equals 0, we will simply return. We will not do any calculation, right? We are not going to do any calculation. If n equals to 1, we will simply return. We are not going to do any calculation, correct? Correct. So these two became a base case. These two became our base case because we know if n equals to 0, we doesn't have to do anything. If n equals to 1, we doesn't have to do anything, right? You can, so that is the improvement, Ekta. So please understand the logic. So this is the mistake you people are doing. You are not getting the logic, but you are going one step ahead. No, Likit, understand the question. I have given the condition n is greater than 1. Please see here. Please see here. N is greater than 1. Okay, n is greater than 1. Likit, for you. So that is why I am not returning -1. I know it will be -1. Okay. So now what will be the recursive condition here? Very simple. Recursive condition will be small sum equals to whatever. So equation minus n minus 1. That's it. What will be the real sum? Real sum will be small sum plus whatever the equation is. We will write our equation here, whatever the logic is. So n minus 1. So it will be math, pow, and by 3. That's it. This is our answer. Are you guys getting it? How simple it is. We solved very complex equation in just 3 steps. So I hope you got little bit confidence now after explaining me, after I have explained you these 3 questions. Anyone facing any doubt? No doubt, right? So I know there are couple of questions which we need to solve, but I want like I am giving you half an hour. I am gonna finish this class early. The reason is I want you to utilize this half an hour to solve at least couple of questions. I am giving you couple of questions list which you need to solve. Okay. Last step once repeat. Okay, I will repeat. So see what is the last step? In last step, we need to calculate the sum. Oh, 1 second. Let me turn on the tab. Just give me 1 second. 7, 5, 4, 3, 2, 1. 1 second. So last step is sum equals to sum small sum, which is coming from this, right? Equation n minus 1, and then we are doing our simple calculation 1 upon math dot pow n minus 1 ki power 3. This is our last step. Whatever we did on the top, the same thing we are doing here. We are not doing anything complex. 1 upon n plus sum, right? And here also we are doing same. So let me write it very clearly so that you people can understand. So it's like I am writing here return small sum plus 1 upon n minus 1 comma 3, and this is pow, math dot pow. This is the step I am writing at the last. Okay, so you have to solve couple of questions. I am just writing couple of questions down. Solve these questions now. These questions now. First will be uh, so I am writing summation of. So Chandu, did you got it or you still have a confusion? 1 divided by n power 5. This is the first question. Second question is print sum of n AP, arithmetic progression. AP stands for arithmetic progression. So these are the 2 questions which you need to solve in next half an hour. We will be meeting tomorrow at 11 a.m. I think. So you know people, right? 11 a.m. is the class, right? Tomorrow, or you don't know? 10 a.m. Is it 10 a.m.? Let me 11 or 10. Just a sec. Let me check. 1 second. Checking. Give me 1 second, please. Invitation. It is 11 a.m. I think. 1 second. Checking. 1 second. It is 10 a.m. Sorry, my bad. It is 10 a.m. So we will be solving. It may extend 10 to 2, but tomorrow we gonna solve many questions. We gonna solve AP. You need to print arithmetic progression. So, Nishant, I will be pushing all the codes on Git because I have done all the codes on the playground. So, I will be sitting today night and I will be putting all the code into my VS Code and then I will be pushing to the GitHub. Okay. First of all, did you guys enjoy today's recursion class or not? Like, give me honest feedback. Else, I need to explain you a bit more tomorrow. But I want if all the 28 or 26 people should be aware about the should know about the uh, recursion. Ekta, please go with your query. Who like the one who like there may be few people who haven't got anything, but I just wanted to heard like what was not great and what you people haven't got. So I know I have done one mistake, like I got confused in Fibonacci series because of 5 input. I am so sorry for that, but rest thing I think I have able to explain in like detailed manner, but it's totally, if you people are not getting, I will be explaining you again. Okay. Someone was asking something. Ekta, please ask your query, or you can
Yes, so
unmute your.
yeah, am I audible?
Yes, please go ahead.
Yes, for the first question that you gave as homework, the one with 1 by n minus 1 to the power 3. So in
No,
that,
no, I have given 1 to the power 5. 1
okay,
upon
yes,
n to
so
the power 5.
fine, fine. So the one you mentioned in the class, 1 by n minus 1 raised to the power 3. So in that question, like my doubt was, if we encounter any negative value, won't it, run into a Stack Overflow exception?
It will. That you need to handle into the base condition,
Yes,
right?
that's what, like, that's why I mentioned the base case as n or less than equal to 1. Instead
Uh,
of, I actually
So
wrote it
I
in the
will I
chat.
will I will I will I will come there. I will come there. So basically that will only come. So that is a very good point, first of all, Ekta. I have mentioned that clearly into the question where n is greater than 1, if you can see. That is why I haven't coded for when
Okay,
n
okay,
is.
okay.
Did you got it?
Yes, yes, yes. Actually, that was my bad. I did like
Yes.
maybe due. Okay, okay.
Okay,
So
fine. But
understood. Thank
that
you.
was a very valid point. Like if you
So
are
that's
solving the.
why I got confused because maybe that was my bad because I did not pay attention to that single detail.
No.
N is always greater than 1. Yeah. Thank you, sir.
No problem, no problem, no problem. So always note, like these cases will be coming in the base cases. Okay. Anyone else have any question? Deepak, there are two questions I have written. 1 second, I am just pasting for you again. I have given the question again. And everyone, I will request you people to remind me tomorrow morning to put the code into the GitHub. Okay. If I forget, I will be doing in front of you. Cool. Okay. So how many people are going to practice after this class and how many people are going to sleep? N to the power 5, not n minus 1. Where I have written n minus 1? Dipanshu, I have clearly written n power 5. Cool. Please practice the question and please verify the responses by putting n equals to 2 or whatever. You just cross check your answers also. Okay. Cool. Yesterday's session, tomorrow's session will be, I will be revising you again recursion because it's a very important topic. And if you will be able to solve these questions, no, then like lead code questions will be very much fun for you. Like if you got the recursion topic completely, then only. If you have any doubt, please do ask tomorrow. It is really important. Okay. Cool. I hope today's session was detailed and I have tried to explain you full recursion, but there are still few things which are remaining. But I want you to first become comfortable with these things, whatever topic I have explained, and then I will be going more into details tomorrow. I will be explaining about the complexity and the step, like how the complexity works in the for loop and in the recursion program, both the things. But for a day, for today and tomorrow, you people are not going to use for loop and while loop anyways. Okay. Please only work with the recursion only. Okay, like this thing. please don't use for loop. Okay. Cool, cool, cool. So cool. I think that's it from my end. Good night to everyone. Cool, 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 cool. Like I will welcome any negative feedback if I am missing anything. Nishant, I told tomorrow I am gonna cover that because it's late, and if I will tell you those problems. You people will be getting overburdened with the things. Those problems are complex, dude. That is why I'm saying wait for one more day, please. Okay, because that is why I kept for the last, because those problems itself are little not difficult, but they are bit tricky. So that's why. What you gave today, we will be discussing these problems tomorrow. Tomorrow's session will be little longer. Like it may be work for 4 hours or 3.5 hours. We'll be taking a proper rest in middle, but that tomorrow session will be little longer. So we be prepared. Okay. Cool. Good night to everyone. And if any doubt, please ask, and the rest all can leave. If someone is having doubt, they can ask from me. I am here. Okay, no questions. Then I am also going. Good night to everyone. Chalo.